Hello, in this lecture we are going to see a problem on Turing machine under the TOC. Draw a Turing machine for equal number of A's and B's. That means very first task to define a language. The language may be ABAB. We can find equal number of A's, equal number of B's are there. The language can be start with BAB. That means it may be start with the B is a starting point or A will be a starting point. Else we can have the A, I will have 3 times B, I will have 2 A's are there. That means equal number of B's and equal number of B. In this language I will have 3 A's, 3 B's. This is completely different than A to the power n, B to the power n. Yes, in this scenario, first all A, then all B. But in our problem statement, what they ask us, equal number of A and B. They haven't talked about the sequence of A and B. So this is wrong. So these are the correct possibility. So we'll try to define first logic. We'll take a language as example. A, B, blank. Fine. So first A will occur, replace with X. I will move on and I will wait for first B is going to occur. First B comes, I will replace with Y. After Y, I will go to the left side. On left side, what I have? X, replace with X itself. While going to right, what I have? B, Y. Y replace with Y itself. Now whenever first X is going to occur, it will be replaced with X. Go to the right side. While going to the right side, what I have? B. Replace with Y. Come to the left side. X replace with X. After that, Y replace with Y. And I will have blank. Blank replace with blank and then stop. This is the one possibility. For this language, what will be there? Blank B-A, B-A. Here we have started with A, here we have started with B. We can perform like B replace with Y. Move A replace with X. While coming I have Y, keep as it is, X, keep as it is. When first B will come, replace with Y. Go to right side. This will come, replace with X. Come to the back, Y replace with Y, X replace with X, blank replace with blank. You can stop there. Now we'll try to draw a Turing machine for the problem statement. Yes, so the problem statement will draw here a Turing machine. The Turing machine may be like Q0 will be the starting state. In the Q0, if A is occur, I will replace with X, move to the right side. And I will wait for first B. Whenever first B occur, I will replace with Y, move to the left side. This will be the state Q2. In state Q2, whenever first X is going to occur, X replace with X, go to the right side. While going to right side, if there are multiple of X, I will replace with X. If there is Y, replace with Y, go to the right side. Wait for A is going to come. As soon as A is going to come, replace with X, go to the right side. And we are wait for first B. Always check first A and first B. First A come, replace with X. If there are n number of A's will come, just skip the element. N number of A will come, skip the element. Go to the right side. We are waiting for first B as per the example. Now let's consider if the start with B. Start with B, replace with Y. Go to the right side. If n number of B's will come, replace of B, go to the right. I will wait for first A. As soon as it comes, replace with X, go to the left side. This will be the Q3, this will be the Q4, and I will go to the Q0. As soon as Y will come, go to the right side. So this will occur if the length of string start with A, it will occur in this part. If the length of string start with B, it will perform in this task. Now where we have to stop? We have to stop at blank. That means whenever blank will come, it will be replaced with blank, no moves. This will be the state Q5 except. So we'll see whatever we have drawn in quick format. So let's consider language equal to AB. So A comes, it will replace with X. If number of A will be there, I will skip. And I will wait for first B. Here is first B, replace with Y. Come to the left side. What I have found here? X. So X replace with X. Go to the right side. On right side, what I have? Y. I have written for Y. Y replace with Y. I will wait for first A. First A is going to come. Replace with X. Then if multiple, there is no multiple. I will wait for first B. Replace with Y. Come to X. X replace with X. Go to right side. On right side, what I have? Y. Y replace with Y. After that, what is the input? Input is blank symbol. For that blank symbol, B is there. B replace with B. No moves except. On the same aspect, if the language start with B. So we have drawn a Turing machine. In a generalized format to accept the language that equal number of A and equal number of B. Keep in mind this Turing machine for equal number of A and equal number of B. I will once again tell you that A to the power n, B to the power n. If you run this problem on the given Turing machine, that will be correct. But what is my problem statement? That equal number of A and equal number of B. So that whatever Turing machine you can draw for this, it may not be correct for this. But whatever you are going to draw for this part, that is also this part. So that in the problem statement, we can't draw Turing machine for A to the power n, B to the power n. We must try to take different kind of languages which is satisfy the given problem statement. So that since the first lecture I am saying that first try to understand the problem statement. In problem statement I have equal number of A and equal number of B. I have defined some languages. After that languages I have to define logic. In define of logic, this is the tape. In the tape we know that there are starting and ending with the blank symbol. In between there is a language. This is the logic. A replace with X, B replace with Y. Come to the left, skip the element, wait for first A replace with X, first B replace with Y. That means in this problem we can also consider that we are waiting for first A. First A comes, replace. First B come, replace. Come back. Skip. First A come, replace. Go right, first B. After replace, come back. That means we have to perform like first A, first B, first A, first B. So that we have to count. If the language is like L equal to A, B, 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 A. This is the language. In this case, A replace with X. B replace with Y. Then I will have first B. So first B, as soon as the first B will come, it will run in this part. That means if A comes, it will run in this part. If B comes, it will be run in this part. So this will be the continuous till all the languages. When it will stop, it is going to the blank. So blank replace with blank, there is no moves. That means we are going to stop. In our problem statement also, whenever Q0, there is blank symbol. Blank replace with blank, there is no moves. That means we are going to accept the string. This is complete generalized form to have the problem on Turing machine, that equal number of A and equal number of B. In this lecture, we have covered the complete generalization form of this problem. So in next lecture, we will see some more problem on Turing machine. Thank you for the listening. Please do subscribe my channel to be updated with the latest videos on GATE. This is the most important question in GATE examination as well as different examinations for the computer science. Thank you for the listening.